Okay, so our next topic for Unit 7 is called parametric equations. So this is a very new concept that you have not talked about. I like parametric equations though because it's going to bring in things that we have talked about over the course of the semester. So parametric equations introduce a new parameter, they're called parametric equations. Frequently it's going to be time. Sometimes it could be an angle. So this will help us where we can tell where an object will be and at what time it will be there. And parametric equations give position, speed, and direction. So once again, if you take physics, or if you're taking physics in the future, you have talked about, or you should be talking about parametric equations eventually. So just to add to that slide, so a lot of times the parameters that we're going to see, and they could be other ones, but t, which normally represents time, or sometimes theta, which represents an angle. So those are going to be the parameters. So instead of our typical x squared plus y squared equals 2, now we're going to have two separate equations where we're going to have a t and a theta, and we're going to have x. Okay. So yeah, let's go ahead and say that. So when we have parametric equations, we're going to have two equations versus just one. Okay, so let me just kind of give you an example. So parametric equations could look like x equals 4 plus 3t, and then you would have another equation for y. We could say 6 minus 7t. These are parametric equations. My new parameter here is t. I now have an equation for x, and I have an equation for y. The type of equations that you're used to looking at are called rectangular equations. And your typical rectangular equations is just like x equals 2y plus 3. So you have one equation here, you just have x and y here all as one equation, and that parameter t is taken away. So parametric equations, we have two different equations. They involve an extra variable, t, theta, some other variable. Rectangular equations are just the equations that you're used to with just your x and your y. So for our first example here, we want to eliminate the parameter, and we want to then figure out what type of curve they're actually talking about here. So they're giving us x equals 1 minus 2t, and they're giving us y equals 2 minus t. So I want you to think about this before we do anything else. So these are called parametric equations because we have this extra parameter here, t, and we have these two equations, okay? So our goal was to change this back to the rectangular equation. So what you want to do here is you can take either equation. You can take the x equation or the y equation, but we want to solve one of them for t. So you really want to solve the easiest one. This one, they're not complicated, but some of them get complicated, so you want to pick the easiest one. So picking y will be the easiest because there's not a number with t there. So what I want to do, just to have directions, you're going to solve for t. So you're going to solve for the parameter. So we're going to have y minus 2 equals negative t. So negative y plus 2 equals positive t. And we can leave it at that. So your first step is to take one of your equations, preferably the easiest one, solve it for the parameter, which in this case is t. Then after that, we want to plug into the other equation. So we didn't use the x equation. So we have x equals 1 minus 2t. So in place of that t, I'm going to put what I solved for up here. So negative y plus 2. So then I can distribute out. So plus 2y minus 4. So x equals 2y minus 3. And that is perfectly fine. That is now my rectangular equation. If you want to solve it for y, you can. But because this is just x and just y, when it asks you for identify the graph, this is just going to be a line. okay, because it's just x and y, there's no squared, so it can't be a quadratic, so it's just going to be a line. So these are my parametric equations that represent this rectangular equation that we found here. Alright, so for the next thing, we're going to be looking at parabolas next. So we know parabolas, quadratics. For parabolas, we have an x squared term, or we have a y squared term, depending on which way it's going to go. Remember, x squared goes up and down, y squared could go to the left or to the right. So I'll kind of go back to these charts once we get finished. But for right now, at the chart, rectangular form, so if the parabola opens up or down, remember we have x squared, left or right, y is going to be squared. You're still going to, for parametric, you're going to have two different equations. In order to represent a parabola, one of your parametric equations has to have a squared inside of it, okay? Depending on if the x is the one with the squared, then it's going to go up or down. If the y is the one with the squared, it's going to go to the left or right. So in order to solve these, if we want to go from rectangular to parametric, we're going to let t equal one of the variables, and then we're going to solve for the other variable. So let me show what that means. So we want to convert y minus 3 squared equals 4x into parametric form. Okay, so right now, I want you to realize that this is in what's called rectangular form. Okay, we only have one equation. We have x's and we have a y, or we have an x and we have a y. Now, y is the one that is squared, okay? So that means that this should either be going left or right. So this is a left or right parabola. Okay, it's really not asking about that, but just so that you can kind of keep in your mind like what we're doing. So we want to make a parametric equation, so we're going to have two equations that we're going to make. So what you want to do here is you want to pick one of your variables to represent t. The other variable we're going to end up solving for. So you can really pick either one. I'm going to pick x first just so I can show you something. So I'm going to let x represent t. If I do that, then I'm going to go back and I'm going to plug in y minus 3 squared equals 4. Instead of the x, I'm going to put t. Now I'm going to need to solve this for y. So do you see that I'm going to have to take the square root of this? I'm going to have to add 3 eventually. So this is not going to be the best option here, okay? It's not going to be the easiest option. It's going to require a lot of work. So let's let y equal t. So if we let y equal t, I'm going to plug in t in replace of that y. And now I want to solve this for x. So the only thing I have to do to solve for x is just divide by 4. So this is t minus 3 squared over 4. So my parametric equations for x, we have t minus 3 squared over 4. And for y, we have just t. Okay, so those represent our parametric equations. They have the perimeter t, okay, there. And so this is our set of parametric equations. Alright, so we're going to do the same kind of thing on the next one. Check out something. Okay. So for the next one, so this is a parabola here. It is in just rectangular, regular form. We need to put it into parametric form. So we want to either let x or y represent t, okay? In this case, you're definitely going to want to let x represent t, okay? So if we let x represent t, and if we go fill in all the x's with t's, it's already solved for y. So at this point, we have our two parametric equations, x equals t, and y equals 2t squared plus t minus 1. Okay, so now we're going to go the opposite way. So if we are in parametric and we want to change to rectangular, this is kind of like the one we did for a line, the first problem we did. You want to take the easier equation and solve it for t, and you're going to plug it into the other equation. So right now, these are in parametric form. Just to make note, because I have this t squared here, I know this is a parabola. So that way you can identify what kind of shapes these are being just from the parametric. Okay, so the easiest one to solve for t would be this y equals 3t. So y divided by 3 equals t. Okay, if you would rather think of it as 1/3 y, that's perfectly fine. Your next step is you're going to plug this in to your other equation. So you get x equals y over 3 squared minus 2 times y over 3. So you can simplify if you want to. This would be y squared over 9 minus 2/3 y. And that is as good as you need to get. Okay. Just some things about this. This is, we already know it's a parabola because of the squared. Because it is y squared, and because it is positive out front, we know it would open to the right. Alright, it doesn't really ask that, but just to relate stuff back to what you already know. So for parabola, just to reiterate, parabolas, if you're looking at the parametric form, they're going to have a squared in either the x or the y. Okay? And when you're looking at your rectangular form, there should be a squared either on the x or the y. So that's how you tell if something's a parabola in rectangular or parametric form.